this video, the goal is to introduce power series. This is going to be the main topic of the final part of the course. So we'll start with explaining what is a power series by comparing it to something we know really well. A polynomial is a function of the form some real number plus some real number times x plus some real number times x squared plus some real number times x to the n. So there's finitely many terms, and each term is some real number times x to some power. So x is a variable. That's the thing that we're putting in. That's the variable that we're going to evaluate. And each ci is just some real number. What is the domain of this function? That is, what is the set of real numbers that we can plug in for x and get something that makes sense? Well, any real number. If your polynomial is something like x to the fifth plus 1, you just put in a real number for x and you get out a real number. So a polynomial is just a function that takes in a real number and outputs a real number. So what is a power series? A power series is like a polynomial, but now instead of having finitely many terms, you have infinitely many terms. So it's a function of the form some real number plus some real number times x plus some real number times x squared plus some real number times x cubed, and so on. So you can think of it as using the sigma notation, a sum from n equals 0 to infinity. And it's important that you start at 0 because we have this first some real number times x to the 0, like just some real number, this constant term. So it's a sum of cn times x to the n. So x is still a variable. We're going to put in a real number for x and see what we get out. And each ci is a real number. But now, it doesn't always make sense to put in any real number for x. Maybe you put in a real number for x, and the series that you get diverges. So we want to avoid that. So the domain, the place where you can evaluate a power series, is the set of all real numbers that you can put in for x, for which the series you get converges. So what is the main example that we're going to start with is something we've been seeing now since the beginnings of our discussions of series. Beginning of our discussion of series. If you let Cn be equal to 1 for every n, then what are you getting? You get 1 plus x squared plus x cubed plus x to the fourth plus, just a sum from n equals 0 to infinity of x to the n. When does that converge? Well, that is a geometric series where the ratio between any two consecutive terms is x. Like for any real number x, you put in x, and you're getting a geometric series where the common ratio between consecutive terms is x. So when does a geometric series converge? It converges when the absolute value of x is less than 1. We saw that if you put in like x equals 1, you just get 1 plus 1 plus 1 plus 1 plus 1 infinitely many times. That definitely diverges. Or if you put in x equals negative 1, you'd get 1 minus 1 plus 1 minus 1 plus 1 minus 1. And the partial sums flip back and forth. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So that series also diverges. But if you put in a real number, let's say r, where the absolute value of r is less than 1, then what you get is a series that converges. And in fact, we know what it converges to. It converges to 1 over 1 minus that number. 1 over 1 minus x, or 1 over 1 minus r, depending on what you're calling the input variable. So this geometric series is our very, very first example of a power series that's not a polynomial. And part of what we'll do in this lecture and in the next one is use this example as a starting point to think about power series more generally. So I'm going to pause and erase, and then I'll talk a little more about power series. Let's start by giving a more general definition of power series than the one we started with here. A power series centered at a real number a is a function of the form some real number plus some real number times x minus a to the first plus some real number times x minus a squared plus some real number times x minus a cubed And you can write it with this sigma notation as the sum from n equals 0 to infinity of Cn times x minus a to the n. And again, it's important to start at n equals 0, just like we did down here, so that we get this constant term C0. So the power series that we defined over here initially is a power series centered at 0. If you put in a equals 0, you exactly get the definition from before. So just to give a concrete example, a power series centered at a looks something like 1 plus x minus 3 over 2 plus x minus 3 squared over 2 squared plus x minus 3 cubed over 2 cubed plus plus plus. How are we thinking about this? Well, it's a sum from n equals 0 to infinity of, well, what is Cn? C0 is 1, C1 is a half, C2 is 1 over 2 squared. You can write 1 over 2 to the n times x minus 3 to the n. That is Cn equals 1 over 2 to the n, and a equals 3. Okay. So like we said, a power series centered at 0 is exactly something of the form that we gave before, but we could have our power series centered somewhere else as well, and we'll see why that's important a little bit later. So what is the main thing that we are asking about power series? Is you start with a power series, meaning you're given an a and you're given a description of Cn. Cn is some description of what these real numbers are. And the question is, for which values of x does the power series converge? So we're going to start with a series, and we want to know what is the domain of this power series. So in the rest of this video, I'll say a little bit about what the possible answers look like. There are 3 main cases, and in the next videos for this lecture, we'll see a number of examples, and we'll discuss like how to tell which case you're in. So I'll pause and erase, and then I'll describe to you what the possible answers to this question can be. The main question we want to answer is, for which values of x does the power series converge? And there are 3 possible answers. Before I say exactly what those are, let's think about one special value. A power series centered at a always converges when x equals a. If you have a power series that's a sum from n equals 0 to infinity of Cn times x minus a to the n, and you put in x equals a, now you get sum from n equals 0 to infinity of Cn times a minus a to the n. Well, that is C0 times 0 to the 0, plus C1 times 0 to the 1, plus C2 times 0 to the 2. Every term past the first one is 0. 0 to the 0 is equal to 1. I'll say more about that in the next video, but you can just take that as a definition, that anytime you see something that is of the form 0 to the 0, that's just 1. So this power series, when you put in x equals a, is C0. It's just some real number. So it converges to that real number. So what are these 3 possible cases? Case 1 is that your power series converges at x equals a. That's always true. But maybe it only converges at x equals a. And if you put in any other real number for x, you get a series that diverges. Another case is that your series converges for all real numbers. That no matter what real number you put in for x, you get a series that converges. And the third case is in between those two. It's that your series converges for all x in some interval around a. What does that mean? It converges if x is in this interval between a minus r plus to a plus r. So r is some real number. A is in the middle of this interval. And you converge, the series converges if you put in something in this series, so some real number in this interval that's around a in the middle, and maybe it goes to a plus 2 and a minus 2, or a plus 10 and a minus 10. Something like that. That if you put in a number close to a, your series converges, and if you put in a number far away from a, your series diverges. This case is of the most interest to us. This interval, the real numbers where your series converges, is called the interval of convergence. And this R that measures the size of the interval, how far away you can get from A and still converge, is called the radius of convergence. So in the next video, we'll just look at some examples of here is a power series for which values of x, which real numbers do we put in for x, and get a series that converges. Is it only at x equals a? Is it all real numbers? Or is it something in the middle? And if it's something in the middle, we're going to want to find this interval of convergence and radius of convergence. And then there's one other little subtle issue, which is we also want to know what happens at the endpoints of this interval when x equals a minus r or a plus r, and we'll come to all of that when we do some examples.